In this video, we're going to be talking about rationalizing radical expressions. Now, there's this rule, long-standing rule and convention that you're not allowed to have radicals in the denominators of fractions. So we're going to have to do what's called rationalizing. Anytime we see that, we basically need to get the radical to disappear at the bottom of the fraction. You're still allowed to have numbers on the bottom and variables on the bottom, they just can't be inside a radical. So there's a very easy way to do this, and I'm going to give you the steps here. Now, note, please, that this is different from what you probably learned in Algebra 2. And the difference is, there are a couple differences. Number one, the method that I'm going to show you, I think, is easier. You're going to end up oftentimes doing a lot less work than you would have doing it sort of the old Algebra 2 work, or the old Algebra 2 way. Number two, the way that you learned in Algebra 2 actually only works sometimes when you're trying to rationalize. Okay, it only works when you're trying to rationalize things with square roots. And we're going to be dealing with third roots and fifth roots and seventh roots in this class. So if you plan on sticking strictly to what you learned in Algebra 2, you're going to get a lot of stuff wrong in this class. So I'll ask you to just go ahead and throw out kind of what you learned back then, and let's graduate on to a different way of doing things. And I think you'll find just as easy, and in a lot of cases, it's going to go a lot faster for you too. So first step, you always want to look at the denominator, and if you can simplify that radical, go ahead and do so. If there's anything you can pull out of there, go ahead and pull it out. There's other things you can do to simplify. In the next video, we'll talk about reducing. If you've got radicals in the top, sometimes you can reduce coefficients and variables in the top and bottom of the fraction. But do whatever you can to simplify if possible. Next, we're going to look at the denominator, the radical in the denominator. We're going to see if it's still left behind, how can we get it to disappear? Now, we can get it to disappear if we can bring everything that's on the inside out. Okay, now if you've got stuff that you weren't able to bring out when you simplified, what we're going to do is we're actually going to add in some extra stuff. Now it seems kind of weird to put extra stuff in to get rid of a radical, but if we make sure that we're able to make perfectly sized groups and nothing's going to be left behind, then we can clear out everything inside the radical and the radical disappears, which is what we're looking for. All right, now in order to bring this extra stuff in, we need to multiply it in. We're going to put it inside of another radical, and we're going to multiply that radical with the extra stuff on the top and on the bottom. Okay, because that's the rule with fractions. If you don't want to change a fraction, you need to multiply by the same thing top and bottom. Once you do this, if you go ahead and simplify, you should find everything disappearing out of the radical in the denominator. You're oftentimes going to still be left with the radical in the numerator, and you may need to go through and simplify that as well. Okay, let's work through a few examples here. So, rationalizing this expression. The first thing I'm going to do is look at my denominator, which has got a radical 7x cubed in it. I'm going to look at that and see, can we simplify that at all? That's a 7 and 3 x's. So, I'm taking a square root. I want groups of 2. I could definitely bring a group of x's out of that thing. I'm not even really worried about what's on the top right now. We'll take care of that later on. But I do have an x that I should be able to bring out on the bottom, which leaves me only with a 7 and an x on the bottom. Okay, now how am I going to get rid of that radical on the bottom? So one of the ways that I could do it is I could look at this and say, you know, if I had one more 7 and one more x in here, then I could group up those 7s, I could group up those x's, I could bring them both outside, and there would be nothing left inside of that radical. So what I need to bring in to make that happen is I need to bring in another 7 and another x. So I'm going to go ahead and do that. Now the way that I do that is by multiplying by another radical that has the stuff in it that I need. I need another 7, I need another x. Now I'm going to have to do that on both the top and on the bottom of this fraction. Once I do that though, here's what's going to happen. On the top, I'm going to have a 5 x squared. I'm multiplying by a radical, so it's going to, that 7x is also going to be inside the radical. On the bottom, I've still got my x, and I got a 7x and a 7x. I'm going to go ahead and group my 7's together, put my x's together, and since I'm looking at a square root, I'm looking for pairs. I can perfectly pair everything up inside that radical on the bottom and bring it all out in front. So now what I've got on the top, go ahead and write this out. I got a 5 and a 7. I'm going to go ahead and write out these x's up here as well. There are 3 of them altogether on the top. On the bottom, I had an x out front to begin with, and I just brought out another 7 and another x. And there's nothing left inside of the radical, so woohoo, we've rationalized. There is no more radical in the denominator. Now we still got to go through and finish this problem up. So let's go ahead and take care of that. Look at the top there, and you'll notice that we do have a pair of x's that we can pull out on the top. So we're still going to have our 5 and our 7 inside of there. And we're going to have one x left inside of there, but we were able to bring another x out on the top there. On the bottom, we've got, let's just go ahead and group these up. We've got a 7 and an x and an x. And I am allowed to cancel these two x's. Neither of them are inside of a radical, so I can go ahead and do that. And I can't cancel anything else. There is a 7 top and bottom, but one's inside of a radical and the other one's not. Same thing with those x's, so we can't cancel those. So we can go ahead and finish this up at this point. We're going to end up with a radical 35x on the top and a 7x on the bottom, and we should be done. All right, let's look at the next problem. Give myself a little bit more room here. All right, so we've got a 2u over the cube root of u. Now, it'd be nice if I could cancel this u top and bottom, but we can't because one's in a radical and the other one's not. Okay, so what can we do? So there's nothing that simplifies here. It's just a single u. I can't bring anything out right now, but I could. If somehow I could end up having 2 more u's in there, since it's a cube root, we could group those together, we could pull them out, we would have nothing left on the inside of that radical. So that's going to be our strategy. Let's bring in 2 more u's by multiplying top and bottom by u to the 2nd power. And it should be the same thing top and bottom. All right, so if I do this, I've got 2u times this cube root, ooh, be careful there, Mr. Heights, times the cube root of u squared on the top over, and then we've got the cube root of u times u squared. That's going to give us 3 u's altogether on the bottom, which should allow us to group them up and bring them out front. Now there's nothing left inside of the radical, so we don't really require it anymore. We would just have those 3 u's coming out in front as a single group. What do we have in the top? We've got a 2u in the top and the cube root of u squared. And we need to try and simplify and look at that radical. We got 2 u's in there. There's nothing that we're going to be able to group up and bring out. We do have a u top and bottom. They're both outside of the radicals, so we can go ahead and cancel those. Final answer here is going to be 2 cube root of u squared. Now this is a problem in particular that you would not have been able to do using the basic algebra 2 method, which was just to multiply by the same radical top and bottom. You would have gotten the wrong answer if you attempted to do that. Same thing with this next one. Let's look at this last example here. Let's see if we can simplify this at all. We've got an 18r on the bottom here. I'm going to split up that 18. That's 2 times 9 minus 3 times 3. Let's go ahead and write this one out. See what we got. Still got this 3 on top. On the bottom, we've got a 4th root. 2 times 3 times 3 times r on the bottom. All right. It's a 4th root, which means we want to try and make groups of 4. We don't have 4 of anything in the bottom there. So we're going to need to bring some more stuff in, quite a bit more actually. I'm going to need 3 more 2s here. I'm going to need a couple more 3s, and I'm going to need 3 more r's to be able to group everything up. So the extra stuff that I'm bringing in consists of 2 times 2 times 2, that's 2 to the 3rd, and 3 squared, and r cubed. And we're going to, of course, have to multiply it by the same exact thing on the top. So 2 cubed times 3 squared, and the 3rd. And those are all both under 4th roots. All right, let's see where we can go from this. On the top, we're going to have 3. We're going to have our 4th root. I'm going to go ahead and simplify this. 2 2 cubed is 8. 3 squared is 9. And on the bottom, if we brought all that stuff in addition to everything that we had to begin with, we should have a group of 2s, a group of 3s, and a group of r's that we can pull out in front. So 2 times 3 times r coming out the front there. All right, let's see if we can simplify anything. We do have a 2 or 3 on the top and on the bottom, both outside of a radical. We can simplify those. And that should be it. That 8 and that 9, I already know what that looks like if it's broken down. It's definitely not enough to pull any groups of 4 out. So, all told on the top, we've got a 4th root. Left over inside, 8 times 9 is 72. We got an r cubed in there. On the bottom, we got a 2 and an r left over. And that's it right there. If you if you're not convinced, you can go ahead and do a factor tree on 72, but you're not going to find anything that'll come out of it. So your final answer. You can find some more examples a bit further down the playlist in another video.